Hi, my name is Guillaume Larocque, and I'm with my colleague, Amin Mimouni, to present a semantic data cloud for biodiversity, a project we've been working on at the Quebec Centre for Biodiversity Science. GBIF has been doing a great job at putting together billions of species occurrences throughout the world. Using the Darwin Core archive format, the vast majority of this data represent an observation of a given species at a given location and a given time. As we know, biodiversity data can be much more complex than that. And for this reason, GBIF recently proposed a Darwin Core data package, which allows for much more diverse data types and much more diverse relationships. For example, data about species interactions, measurements on species, measurements on the environment, genetic data, different types of media can all be stored using the Darwin Core data package. However, this will create much more complex data structures. And then the question is, how will we find this data? How will we access it? How will we interoperate with it? And how will we make reproducible science with it? So what we propose is a semantic data cloud for biodiversity, which is currently a proof of concept. It stores data and metadata in structured and distributed catalogs, which are inspired by stack catalogs, which are used for geospatial data. It allows for queries that understand the complex structure of data. It allows querying data remotely and efficiently at scale. It can also make large language models understand the structure of the data to provide more informed and rigorous answers to questions.
Hello, I am Emin Mimouni, a research professional at the QCBS, and I will explain in more detail the core components of the application and how it works. It all begins with Darwin Core data packages being hosted as Parquet files on the cloud. The user will send a query along with optional spatial, temporal, or license filters. Based on these filters, the dataset metadata catalog will determine which datasets should be considered and which should not. Following this, the query is considered. However, the query language is not SQL, but Sparkle. Sparkle is an exciting and expressive declarative query language that enables precise extraction of specific data across multiple related data entities and is a W3C standard. As can be seen from the example query, the application considers, among others, Darwin Core and Dublin Core terms, and has a built-in OWL ontology which define classes and properties considered. One possible solution to the query is shown here, and it shows that biodiversity data can be quite connected and is extremely well represented by a graph-like model such as RDF. However, consideration of RDF would have required a triple store and led to duplication of data, which this application does not. Instead, the application considers an OBDA approach, wherein queries are converted by OnTop from Sparkle into SQL, which is executed by DuckDB, leveraging its affinity for Parquet for SQL execution. Following this, the Sparkle JSON results are returned to the user. The process has created a virtual knowledge graph, which existed only ephemerally during query time. Finally, the application also considers MCP, exposing the Sparkle endpoint not only as a tool for users, but also for LLMs, which can understand and therefore act on it. A live version of the application considers over 50 datasets that have been taken from GBIF and converted to the exploded Darwin Core data package format described. It is currently running on data.qcbs.ca, and you can interact with the various services and endpoints provided by the application. In conclusion, this application solves a real problem, which is how to create several datasets in a semantically clear fashion. Thank you for your attention.